Equations of uniformly accelerated motion. That is, for objects that are moving in a straight line. That is, objects that are moving on the ground. We can write that V is equals to U plus AT. That is the equation 1. I will tell us what each of these parameters represent. The equation 2 is S is equals to UT plus half AT squared. That is our equation 2 that we can use for any uniformly accelerated body. Then the third one is V squared is equals to U squared plus 2AS, and that is our equation 3. Now, you might be wondering, what does U stand for? U is our initial velocity. V is our final velocity. T is the time, that is the time taken for that motion. S is the distance covered or the displacement of the object. A is the acceleration. Okay, now we can rewrite these three equations. We can rewrite these three equations for an object that is moving under gravity. For an object that is moving under gravity, we mean an object that you throw up, okay, and then it will also come down. You throw it up with an initial velocity u, it will go up. At the maximum, your final velocity is 0. Okay, so for the going up, that is the first part of the motion, is that object that you throw up is moving under gravity. So it will go up, you throw it up with a particular initial velocity. The velocity keeps decreasing until it gets to the maximum, that is the maximum height. At the maximum height, the velocity becomes 0. So the object stops momentarily, although you may not be able to see it, but the object is going to stay momentarily for a short period of time when its velocity has become 0 before it starts to come down again. So this, for the second part of the journey, that is when the object is coming down, our u, which is the initial velocity, is 0, and our v, then the velocity keeps increasing for that object. When it is coming down, the velocity keeps increasing until it gets to a maximum just before it drops on the ground, until it gets to a maximum just before it falls to the ground. Okay, so while going up, the velocity of the object is decreasing. While coming down, the velocity of the object keeps increasing. Okay, so for these three equations, v is equals to u plus at, s is equals to ut plus half at squared, v squared is equals to u squared plus 2as. We can write the equivalent for an object that is moving under gravity. Okay, so we can write that v is equals to u minus gt, where our a now becomes g. Okay, so the normal acceleration for an object moving on the ground is now the acceleration due to gravity for an object that is moving under gravity. Okay, then our h is equals to ut minus half gt squared. That is for when the object is going up. When the object is going up, we will use minus. When the object is going up, we will use minus. Okay, and the third equation is v squared is equals to u squared minus 2gh. Okay, where we have changed a to be g for motion under gravity, and we have also changed s to be h for motion under gravity. Okay, so what we are simply saying is that instead of our normal distance, a height is now covered. Okay, and that height is what we have represented with h. But when the object is coming down, when the object is coming down, instead of minus, we will put plus. We use plus when the object is coming down. Okay, and why is that? Because the object is moving in the direction of the force of gravity. Okay, the object is moving in the direction of the force of gravity. Okay, so we can write that v is equals to u plus gt. Also, h is equals to ut plus half gt squared. And the third one, v squared is equals to u squared plus 2gh. Many students have asked me, how do they know? How will they know the equation to use for a specific question? Okay, and this has been always been my answer. Okay, when the object is going upwards, you use minus in your equation. When the object is coming down, you use plus. Okay, so when you are given a question, just check, is the object performing the motion under gravity? Is it going up or coming down? So if it is going up, use these equations. If it is coming down, use these equations. Okay, so that will um, provide for a lot of headache that you would have had in attempting or solving such equations. Okay, but what about for um, an object that is performing projectile motion? That is, an object that is moving along a parabola, an object that is moving along a parabola. Okay, so the object is shot at an angle, or the object is thrown at an angle. Can we use the equations of motion also for such a motion? Yes. The answer is yes. We can use the equations of motion for such a projectile motion. Okay, and what we will do is we will write our equations, that is for when it is coming, when it is going up. Okay, this ones, when it is going up, I will write it along the vertical and along the horizontal, because for an object that is performing projectile motion, two motion is happening simultaneously. That object is moving up and at the same time is moving forward. An object that is thrown at an angle to the horizontal is performing two types of motion. The object is going up and at the same time the object is moving forward. Okay, so going up, it is performing vertical motion. Moving forward, it is performing horizontal motion. Okay, and we have to take these two motions into consideration when we are trying to attempt or solve a question under projectile motion. Okay, so we can write these three equations for when going up for the vertical motion. Okay, so the first three that you see here, they are for the vertical motion of the object that is performing projectile motion. Okay, they are for the vertical motion. So that's why I've written that v vertical. Okay, so this v subscript v that you see here is v vertical is equals to u vertical, which is the u subscript u, minus g vertical t. All right, yes, so the acceleration due to gravity is also vertical. Okay, because they are vector quantities. So all the vector quantities in the equation can either have vertical or horizontal component. They can either have vertical component or horizontal component. So I'm writing for the vertical first. Okay, then for the height, okay, for this height, I will write h vertical is equals to u vertical multiplied by t minus 1 over 2, 1 divided by 2 g vertical t square. Okay, then for the third equation, I will write v vertical square, that is v subscript v square, is equals to u vertical square minus 2g vertical h vertical. Okay, there are two also types of art that could be covered by that object that is performing projectile motion. Don't forget it's moving upward and at the same time it's moving forward. Okay, so if I'm to write the horizontal component of the motion now, the horizontal component of the motion using my three equations for when going up, using my three equations for when going up, I will write v horizontal, okay, is equals to u horizontal minus g horizontal t. And take note, my g horizontal is always 0. My g horizontal, that is the horizontal component of the acceleration due to gravity, is always 0. You will say why? Why? The reason is because the acceleration due to gravity is acting vertically downwards, and therefore the uh, horizontal component is 0. It does not have effect along the horizontal. So the horizontal component is 0. Take note of that. Then for the second equation, I will write h horizontal is equals to u horizontal multiplied by t minus half g horizontal t squared. Don't forget our g horizontal is 0. Okay, then for the third equation, I will write v horizontal square is equals to u horizontal square minus 2g horizontal h horizontal. Okay, so those are the three equations for the projectile motion. Okay, this is for the vertical component of the motion, that is when it is going up vertically, and this is the horizontal component of the motion, that is the one that is making it to move forward. Okay, so I can also write for when it is coming down. When the object is coming down, I will just change where I have minus sign to plus sign. Okay, so I will just change where I have minus sign to plus sign, and that will give me for when it is coming down. So when you are trying to solve an equation, a question on projectile, check, is the object going up? If the object is going up, you use these equations. If the object is coming down, change your minus sign, the minus sign, change them to plus sign, okay, and then apply the equations appropriately. I hope you understand what I just explained. See you in the next class. Goodbye.